out at the same time. I get all kinds of criticism for killing trees, etc., etc. Where have we been?
Wait, what's we have to finish the pretest.
You know what? If you have a key card, you don't get stuck. Okay, then I guess you'll just get it started.
I don't know.
All right, so get your packet out. It's that is the first page. Looks like this. It says arithmetic and geometric sequences in series. No, it's in its own packet. I didn't label it. I know what it is, but I didn't label it. It's the one that looks like this on the front page. Okay? And we are going to actually look at page 3, the front of page 3. And we are not going to do all of these problems. But what we are going to do is talk about the difference between these first 3 on this page. So we're on page 3 of the packet, whose front page looks like this. Last time, front page looks like this. We're going to page 3 of that packet. First question. Alana is practicing for the All-World Golf Championships. She only has 9 days to prepare. If she hits 5 golf balls on the first day, 10 on the second day, 20 on the third day, and so on, how many balls will she hit all together during her 9 days of practice? Now, can you tell me what's going on in this problem? First of all, if you wanted to, you could actually write out all 9 days, right? This is day 1, this is day 2, this is day 3. What would day 4 look like? 40. And day 5 would look like 80. How are we getting from term to term here? We're multiplying by 2. Does anybody know what a set of numbers is called where you get from term to term by multiplying by the very same number? Well, it's a sequence. What kind of sequence? It's called geometric. A geometric sequence is one in which you get from term to term by multiplying by the same number. Okay? Now, in this case, the number we're multiplying by is 2, and that number is called the common ratio. So this same number is called the common ratio. So for this problem, the ratio is 2. Now, with sequences, there are basically 2 things that are going to happen. Either the question will say, how many golf balls will she hit on the 9th day? Or the question will say what it does, which is how many will she hit altogether in those 9 days. What's the difference between those 2 questions?
One's asking for how many on one day, one's asking for the whole number.
So one is asking for just what would be, if I wrote all these out, what would be the 9th number in that list? And the question we have, though, says, no, I don't want the 9th number in the list. I want to add them all up. Do you see what I'm saying? So one question could be, how many golf balls does she hit on the 9th day? That would be that number right there. This is the first day, second day, third day. That would be the 9th day. Your problem says, how many will she hit altogether in 9 days? If you want a term of a geometric sequence, the formula you're going to use is this one. Now, if I had time to go through a whole bunch of stuff, I'd explain where that formula came from. We derive it. It's real easy. But you're just going to take my word for it. That the nth term, so in our problem it would be the 9th term. The nth term is the first term times your common ratio, which for our problem is 2, times the number of terms minus 1. So if we wanted to know how many golf balls she hits on the 9th day, we would say A sub 9, that's the 9th term, is 5 times, what did we say our ratio was? 2. And we're going to go to the n minus 1 power, so that would be 8. So on the 9th day, she is going to hit a lot of golf balls. Oops. 1,280 golf balls. So that's how many she hits on the 9th day. Now, was that our question? No. Our question was, how many will she hit all together? Now again, one option you always have is to figure out every term and just add them up. That will always work. When there's only 9 of them, that's not too bad. But if there were 90 of them, you wouldn't want to do that, would you? No. So I'm going to give you a formula. This is to find a term. I'm going to give you a formula to find the sum in a geometric sequence. The sum of n terms. So S is going to be our sum. That tells us this is a sum formula. Is a sub 1 minus a sub 1 r to the n over 1 minus r. Now, what does the a sub 1 stand for? I already told you. A sub 1 stands for the first term. What does the r stand for? Ratio. What does the n stand for? Okay, we got everything we need. So to answer the question on the paper, we want to add up those 9 terms. So we'll have 5 minus 5 times 2 to the 9th over 1 minus 2. Negative 1 on the bottom. So here we go. 5 minus 5 times 2 to the 9th. So she's going to hit 2,555 golf balls over the course of these 9 days. These two formulas you can use in any situation that is geometric. And again, what does geometric mean? You get from term to term by multiplying. You could make up a set of numbers that's not geometric. If we get from term to term by multiplying, those are your formulas. Okay, now I want you to look at the next problem. In the first game of the season, Barry caught 8 passes. Then he caught 11. Then he caught 14. Okay, now wait a minute. We went from 8 to 11 to 14. Is this geometric? No. How are we building this set of numbers? We're adding. And when you add the same number to get from term to term, it's called arithmetic. Now I know the word looks like arithmetic, but when we use it as an adjective, it's arithmetic. So an arithmetic sequence is when we get from term to term by adding the same number. So geometric, those are the two formulas that are circled that are going to get erased in a minute. Those are the formulas you use if you're generating a sequence by multiplying by the same number to get from term to term. If we're adding the same numbers to get from term to term, obviously we have different formulas. If we want a term in the list, our formula is this. know what this means. This means the nth term, the term I'm looking for. What's a sub 1? First term. Uh-oh, this is new. What do you think the D stands for? What you're adding. It's called the common difference. And it is the number that you are adding. So in our problem, D is 3. If we want a sum, if we want to not just make a list, but we want to add them all up, the formula for a geometric is this. And I got a real cool story about that formula. I wish I had time to tell stories. Maybe someday I will. Write it down. That's your sum formula in arithmetic series, an arithmetic set of numbers. So you had no problem, even without any discussion. You knew this problem was arithmetic. You looked at it, you said, okay, I'm going 8, 11, 14, that's arithmetic. Immediately then you narrowed it down. It's going to be one of these two formulas. Read the problem again. If he keeps up this pattern, how many passes will Barry catch in the 14th game? Do we want a term or do we want to add them all up? We want a term, don't we? What would the problem say if we wanted to add them all up?
How many passes will Barry catch in all 14?
Or how many passes will he have caught by the end of the season or something like that? We want a term. So the answer to question number 2 is, which term do I want? I'm adding up 14, so I want to know what's the 14th number in this list. Now again, kids, could you write out 14 numbers, but just keep adding 3? Absolutely. If it were 140, you probably wouldn't want to do that though, so you want to get comfortable with these formulas. The 14th term will be the first term plus the common difference times n minus 1, which will be 13. N is 14. So n minus 1 is 13. So what is that? 47? Is that okay? All right, I'm almost done for the day with this, and then we'll go back to your pretest. But here's the scoop. When you read one of these problems, and they're almost always going to be word problems, or just all word problems, when you read one, what's the first thing you have to decide? Well, even before you decide sum or term, you probably want to decide arithmetic or geometric. It really doesn't matter what order. Those are the two things you got to decide. You got to decide if it's arithmetic or geometric, and if you're looking for a term, or if you want to add them all up. Okay, so let's try that with number 3. Frances gained 10 votes in the queen contest. She gained 16 votes on the second day, 22 votes on the third. How many votes will she have garnered altogether if the contest runs for 90 days?
That's a sum.
Well, it's going to be a sum, and the clue is you got to read the sentence. How many will she have garnered altogether? That's a sum. Arithmetic or geometric? Arithmetic. So this is the formula, then you've narrowed it down. As soon as you tell me it's arithmetic and it's a sum, then I know it's that formula. So here we go. How many am I adding up? Whoa, whoa, whoa. How many will she have garnered altogether if the contest runs for 90 days? Isn't that 90? Don't I want to add up 90 of them? So it's going to be 90 over 2. All right. Then what?
10.
The first day was 10. Oh, shooty.
So we took the terms.
What's going to go right here? No, not 90, not the number 90. What's going to go there? A sub 90, which is the 90th term. Do I know that?
No.
This is what I know so far. This is what I know so far. I have no idea what the 90th term is. Can I figure that out? Yeah, but now I gotta use this one. So over to the side, the 90th term is the first term, plus the difference, which is 6, right? Times 89. This happens all the time with this formula. I love this formula. Got a great story about it, but this is a pain in the butt. It happens all the time. I got 544. Now what does that 544 represent?
The 90th.
That's how many votes she got on the 90th day. So if I wrote out my whole list, that would be the last number here, which is exactly what I need here. So the answer to the question is 24,930. You okay with that? Okay, turn it over. Let's do a couple more. We're not going to do all these. We're on the back side of that same page now. Let's look at the first one. Tyler ate 2 M&Ms on the first day of his vacation. He ate 7 on the second day. Uh, 12 on the third day. How many M&Ms will he eat altogether on his vacation? So it's arithmetic because we're going from 2 to 7 to 12. Everybody recognize that's arithmetic? Formulas for arithmetic are these. You have these written down on your paper and you don't have to memorize them. I'll give them to you. But you have to know the arithmetic. I'm not going to tell you the arithmetic. You need to know those, the arithmetic one. So, which one do I need? How many M&Ms will he eat all together? So I'm going to sum how many days? As sub what? 12. 12 over 2. First day is, oh crap, I told you this happens all the time, right? Here we go. Here we go. What goes in that last blank? This 12th term, which I don't know. So over to the side, I'll figure out that the 12th term is the first term, times 5, the common difference, times 12 minus 1 or 11. So that's 57 M&Ms. So the answer would be 354. All right, let's go down to number 7. Stephanie went to the mall each day for 8 consecutive days. She spent 2 cents on the first day, 6 cents on the second day, 18 cents on the third day. How much did she spend all together? Okay, what kind of sequence do we have? Geometric. How much did she spend all together? Sum. So your geometric sum formula is this one. So here we go. We're adding up how many days did she go to the mall? 8. So we're adding up 8 days. The first day it was a 2. What's my ratio? What am I timesing by? 3. And N was 8. Alright, so here we go. I always just type in my numerator, 2 minus 2 times 3 to the 8, hit equals, and then divide by -2. So she spent $65.60. Remember, these were pennies, so when I got that big number, I changed it to dollars. Okay, that gave us a good start on those. kinds of problems, all right? So now we'll go back to your, what we need to do to get ready for tomorrow's test. And we need to finish the pre-test. And we're ready for number 8?
Yeah.
Okay, and then there are a couple other things I want to just mention real quick, but let's do number 8. Start with number 8. Here we go. Ted, Charles, Reese, and John run a race. How many ways can they finish? Assume there are no ties. Answer? There's 4 of them. So one idea is 4P4. Beautiful idea. Why? There are 4 boys. All 4 of them are going to run and finish the race, right? Does order matter?
Yes.
Yeah, so there's 4 kids. I'm picking all 4, and order matters. Did anybody have a different thought? Think about the race. 4 factorial. These 2 things are equal. So if you thought about it as 4 factorial, you're fine. That's the same thing. They are exactly the same thing. So it's whichever way you thought about it. All right, in a certain school, I've got 540 seniors. 335 are taking math. 287 are doing this. 220 are doing both. What setup are you thinking when you look at this? You're thinking what? Venn diagram. Absolutely. Anytime you've got overlapping sets, at least think about doing a Venn diagram. And where do we always start filling in our Venn diagram if we can? The middle. Do I know the together? Do I know the overlap part? I do. It is 220. How many people then are here?
115.
This is the math wall, and there's 335 math kids, so 115? How many are over here? 67. Now, keep in mind, there are 540 kids in that box. How many of them are in the circles? 402 are in the circles. What does that mean about the other, 138? Where are they? They're out here. And what are those 138 kids? They're the ones that don't do either one, right? So how many seniors are taking neither math nor science? 138. So now I have a big box. All seniors are in here. 540 seniors are in this box. I'm going to reach in and grab one kid out. What is the probability that he's taking only math? 115 over 540. Right? Don't make it harder than it is. You're only pulling one out. There's 115 possibilities out of a total of 540. Right? All right, read number 10. What is your thought about this?
Does she grab one from each team?
Oh no. She only gets one treat.
So is there 2 different scenarios?
This isn't going to be a Venn diagram. This is a tree diagram. Why is this a tree diagram? Because her probability of getting a brownie depends on what? Which tin she's in, right? So the first thing she has to do is pick a tin, A or B. So you walk into the room, there's 2 tins on the table here. All right, you're going to grab a treat. Well, what's the probability you'll grab it out of tin A? 1/2, 0.5. I don't care if you use decimals or fractions, makes no difference. And then tin B is 1/2. Now, once you've decided, okay, I'm taking it out of that tin, then you're going to get a brownie or a cookie, right? If you're in tin A, what is the probability you'll get a brownie?
What is it, 12 out of 1?
12 22s. Aren't there 22 things in the tin and 12 of them are brownies? Which means 10 22s will be the cookie. Now, what if you go to tin 2? Then a brownie would be 16 18ths and a cookie would be 2 18ths. Now, the situation is you want a brownie. So you can either get a brownie out of tin A. In other words, you pick tin A and a brownie. Or you could pick tin B and a brownie. So the answer to your question is that fraction plus this fraction. And you can answer that as a fraction or as a decimal, whatever you are more comfortable with. All right, we've done about a zillion trillion of these. I think you probably have this under control. How many ways can the letters of the word "you are special to me" be arranged? What do we need to do? Count the total letters. So I don't know how many there are, however many letters there are. And then what do we do? Once we count them up, it's that factorial. So if there's 30 letters, it's 30 factorial. Divided by any repeated, right? So if you have 5 O's, it's 5 factorial. If you have 3 S's, it's 3 factorial. And you just divide by everything that is repeated. Keeping in mind that if you're typing that into your calculator, you're going to have a bunch of stuff in the denominator. Make sure it's in parentheses. Suppose a coin is tossed 6 times. What's the probability of exactly 4 heads? What's your strategy on this? Anytime you do any kind of repeated activity, like flipping a coin, rolling a die, having a baby, guessing on a test question, anytime you do an activity over and over and over again, where the probability of what's going to happen is not dependent on what's already happened. What I mean by that is, it doesn't matter if you flip a coin 30 times. Every time you flip it, the probability is 1/2 for getting heads, right? Right? So that, anytime you have that situation, you're going to, the best way, the easiest way, is to say, well, the probability of getting heads is 1/2. The probability of not getting heads or getting tails is 1/2. In this problem, I want 4 heads and 2 tails, and the number of ways I could do that is 6C4. So, this is a Pascal's triangle problem. The difference is I didn't draw the triangle to get my numbers, I just said 6C4. Now, why did I say 6C4? I'm going to roll it or flip it 6 times. And I want 4 of those. I'm going to pick 4 of those to be heads. Order doesn't matter. Any 4. And then I have the 2 probabilities. So that would be the answer to the problem. Okay? If I said to you, roll a die 12 times, what's the probability of 5 ones? You would do it exactly the same way. Your probabilities are 1/6 and 5/6. This is a 1, not a 1, right? If I wanted 5 ones, this would be a 5 and this would be a 7 because I have 12 rolls. And then the number of ways I could do that is 12C5. I'm going to roll it 12 times and I'm going to pick 5 of those to be heads, or to be ones. Got it? Now, Those problems can be done with a tree diagram. The problem with the tree diagram is it gets huge. In those problems, it gets absolutely gigantic. So I would suggest that anytime you're rolling a die, flipping a coin, guessing at a test question, whatever, that you think about setting it up here with the binomial probability. Okay, as I was checking your homework, there seemed to be a problem that was an issue. It was on the sheet called morning practice, and it was number 6. Now there may be some other issues, but I want to look at problem 6 on the this is page 9. This was part of your assignment. You turned it in. Some of you turned it in, and it's page 9, number 6. Some of you got it, but a lot of you either left it blank or had some bogus stuff down here. So here we go, number 6. I got 800 students in the school. 490 passed algebra, 340. Okay, so I'm kind of giving it away because it's just automatic to me that this would be Venn diagram. Does it feel like a Venn diagram to you? You've got groups of people overlapping each other. Okay, so I got these algebra kids and I have these geometry kids. Now, where do I start with a Venn diagram? Where do I like to start? In the middle. We have a problem here though, because they don't tell me how many kids passed both, right? But they do tell me what? I didn't pass either one. So you've got 110 kids out here in this part of the Venn diagram. Would you agree with that? Okay, now I want you to think about this. Pretend I have 800 children in the room, all right? And I say to this group of 800, if you didn't pass either one, get out. So now 110 kids have left the room. How many kids are left in the room? 690. So there are now 690 kids in the room. And I say, all right, if you passed algebra, raise your hand. So 490 hands went up, right? I say, okay, now, put your hand down. If you passed geometry, raise your hand. And 340 hands went up. So a total of 830 hands went up. Would you agree with me? But wait a minute. There's only 690 kids in the room. If there's only 690 kids in the room, but 830 hands went up, what does that mean?
160 did vote.
140?
Yeah.
140 raised their hands twice.
No, you're right.
You only have 690 kids in the room. If 830 hands went up, then somebody raised a hand more than once. 140 are in the overlap. If there's 140 in the overlap, then there must be 350 here and 200 here. What should these add up to? No, these should add up to 690. With that 110, we give you your 800. So then the question said, how many passed only algebra? The answer would be 350. See how we figured that out? Had to think about it. All right, that is the one I remember people missing. Was there anything else that you can remember on this homework sheet? Anything bother you on the homework sheet? Rest of it you felt okay with morning practice?
Yeah.
Okay. Was there anything else you found as you were studying, you know, doing review sheets or whatever? What?
Did you do number 5 on the reviews?
On the morning practice?
Yeah.
Okay, why didn't you tell me that before I turned the page?
Sorry, that's my fault.
You said number 5? So the probability of my getting an A on a pre-calc quiz is 0.62. Find the probability that you'll get at least 4 A's in the next 5 quizzes. Now, what does at least 4 A's in the next 5 quizzes mean? I could get 4 or 5. So this is, you know, anytime you have an or problem, it's gonna be like 2 pieces and you're gonna add it together. So we could get 4 A's, or we could get 5 A's. Now we have to do one at a time, always, always, always. Even on the tree diagram problems, you do one branch at a time. So here we go, 4 A's or 5 A's. This is exactly like the rolling a die, flipping a coin problem. Because every time I take the quiz, what's gonna happen? I'm gonna get an A, or I am not gonna get an A. Now, when I flip a coin, the probability of heads is 1/2, and the probability of tails is 1/2. What are you doing, Jay? Okay, well, let's pay attention up here, okay? By the way, you did great in the volleyball game the other night. That one kid hits really, really hard. I can't remember his name, but he hits the ball really hard. All right. So here we are. What's the probability of getting an A? When I flip a coin, it's 1/2, 1/2. What is it here? 0.62.38. Those are the probabilities of getting an A or not getting an A. Right? That's it. Now, how many A's do I want? I'm doing this case. How many A's do I want? 4. And I want 1 not to be an A. Now, what's missing out here in front? The number of ways that I can take, the number of ways that I can take 5 quizzes and pick 4 of them to be A's. Remember when I flipped the coin 6 times and I wanted 4 heads? This is the same thing. Now, what does 5 A's look like? It's going to have the same setup.
Except the thing is going to be 0.
That's going to be 5 and 0, and this is going to be 5C5, because I want to pick all 5 of them to be A's. And that's your answer. Those 2 things added together.
6.62, would you put the 6 in that?
What?
Isn't it 6.62? No, it's just 0.62.
Okay, first of all, probability would never be 6.62.
On the paper, it looks like there's a 6.
That's an is. The probability on pre-cal quiz is 0.62. If you're asked to work it all out, yeah, you type it in on your calculator and you get some decimal as your answer. All right? Jack, is your hand up? Okay. Anybody else before I turn the page? Anything on any other page you found or in a book problem that you found? Some of you are in a must-pass situation. Let's make this good tomorrow.
Okay, let's go review.
Could you put up the answers like after I take my check?
What page is it?
So like number 5 on the green sheet says the back of 5.
So it's the back of page 5.
I think it was just saying that number 5 was on the back.
Yeah, those are answers.
Yeah, but I didn't provide the answers in the packet to do this. If I have a chance, I will work these out and hang them. I'll hang them out in the hallway. I'll hang them out in the hallway, so you can come check them, like in the morning, or I won't. I have class the rest. Oh no, maybe I will have time at the end. Maybe I can get it up before the end of the day. Get it done by the end of the day. But no, I'm not going to put them anywhere like online or all that crap. No.
So you can get them done before 3:05?
I might be able to. It depends.
Did you like email if you did
No.
that? No.
No. You can like jog down here and look real quick and they'll be hanging right outside the door.
At 3:05.
What you could do is actually communicate with one another. Hey, did you get 0.37 number 1? That could happen. ask the right person, and it probably won't. Yes, if I hang them out there, one person could take a picture and, I don't know, Snapchat it or whatever you guys do to communicate. All right, I'm going to make up a problem. What?
Like just in advance, are we not gonna test them in line 4 and 5?
We're gonna have a test over something. I'm not sure whether it will be. Well, we have chapter 7 to go too.
In a week?
So we have 2 weeks, and I'm not sure how I'm gonna handle all that, okay? Not sure. We've already done some very basics of 9, 4, 9, 5.
What did we just learn?
9, 4, 9, 5. We just learned the basics of 9, 4, 9, 5. All right, so I'm just gonna pick one off this sheet. I'll just do the last one. Number 10. How many 5-card hands will have more red than black? How many 5-card hands will have more red than black? Okay, now wait, what does more red than black mean in a 5-card hand? It means 3 red, or 4 red, or 5 red? All right, how many will have this? All right, let's do 3 red. I need a 5-card hand that has 3 red. 26C3, there's my 3 red. And 26C2, there's my 2 black. Because I need 5 cards. 3 of them are red. Or, all right, what would 4 red look like? 26C4. 26C1, because 4 red would mean 1 black, right? Now, 5 red, 26C5, and you can stop there or add if you want to add on 26C0 if you wanted to just say no black. That's easy, no issue there. All right, let's try the one right above that.
So you'll want us to multiply all that out?
Yep.
Right?
You'll take my directions, whatever I say tomorrow. There's a 65% chance that lacrosse practice will be held on any given day. If there's no lacrosse, there's a 10% chance Adam does his homework. Or excuse me, if there is lacrosse, there's a 10% chance he does his homework. If there's no lacrosse, there's a 42% chance he'll do homework. Find the probability that Adam will not do his homework on any given day. Tree diagram. Definitely a tree diagram, because what's happening? Either there's lacrosse, what is it, LAX, or there is no lacrosse, right? Then he's either going to do his homework or not do his homework. All right, what's the probability we have lacrosse? 0.65. So this would be 0.35. If there is lacrosse, okay, so if there is lacrosse, there's a 10% chance he does his homework. If there is no lacrosse, then there's a 42% chance he does his homework. So what's the question? Not do homework. So not do homework would be 0.65 times 0.90, or not do homework 0.35 times 0.58. That's the answer to that one. Easy, easy. All right, I'll see you tomorrow. Get here fast. Get here fast.